Hey, what's up guys? I'm Dave Boyer, aka Mr. Boyer, aka the Swamp Man. I'm here at Topsail Island. My family's on a little quick vacation just for the weekend, enjoying the beach here. Our first unit of study is going to be waves, and we're going to focus mostly on sound and light waves, and then later in the year we'll kind of transition to earthquake waves. But all those waves have something in common, and that's that they can be measured by their properties. There's three properties of waves. You have wavelength, frequency, and amplitude. And all of those can be described using the ocean waves that are behind me. So frequency might be the easiest one because you've maybe heard that word before. Frequency is how often something happens. So like, you know, I eat 3 meals a day. That's a frequency. 3 meals in one day. That's counting something over a time period. So waves, you can count the number of waves over a period of time that happen behind us. And we can measure that as the frequency of waves. As I'm looking back there, there's 1, and then 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000. So it looks like it's about 1 wave per 6 seconds out here right now. What's kind of crazy is that these waves that are crashing on the beach here generated maybe 2,000 miles away over the open ocean. The wind blowing across the ocean. Maybe there was a big storm, because storms often cause these waves. And they push the water along the surface, and they send that water towards land in all directions, or at least in the direction the wind is blowing. So these waves have been traveling across the ocean. The energy from the waves have been traveling across the ocean. And as they get in towards land, there's nowhere for the wave cycle because it moves in a circle. There's nowhere for it to go down below because the slope of the land has come up. It's really shallow here. So the bottom of the wave is striking, the bottom of the land is striking the bottom of the wave, and that's causing the wave to carry over and crash on the land. So you have frequency, the number of waves per unit of time, like waves per second. You can also measure the wavelength. The wavelength is measured as the distance between 2 crests of the wave. So if we saw a wave crashing, that would be a crest of the wave. If we look back to the next wave that's coming in, we can measure that distance in meters. I don't know, here it looks like maybe about 20 meters or so between one wave and the next wave. So that's measuring the wavelength. The third property of waves is the amplitude. And the amplitude is like the height of the wave. It's a measurement from the distance of the rest position, the medium position, up to the highest position, the crest position. So from rest to crest is amplitude. So we got a meter stick out here, not like you play around with a meter stick on the beach, but if we got a meter stick out here and measure the height of these waves, we can determine their amplitude. We might get an amplitude of about 1 meter here in Topsail Island. We don't get the biggest waves here. It's not like surfers are going to compete in competitions here at Topsail. They don't have giant waves like they do on maybe like the North Shore of Hawaii. So you got frequency, the number of waves per unit of time. We've got frequency, wavelength, which is the distance between crest and the next crest of the wave. And then you have amplitude, the measurement of the rest position up to the crest position, also sometimes called the height of the wave. So it's pretty cool to kind of see some ocean waves and kind of use those as an example of the types of waves that we'll study. I'll talk to you later about how we can relate that to sound waves and also light waves. But I wanted to share a little bit of Topsail with you, talk about waves that are crashing behind me, and tell you that science rocks. Peace.